Can you see my screen now, everyone?
Yes, perfect.
Okay, perfect. Cool. People I think are still joining, but welcome everyone. It's great to see everyone joining for this session today. We're trying to have these sessions more often. I will start a recording and we will be publishing also this on our website afterwards. Let me just start the recording. Is the recording on? Oh, I think it's automatic recording. Recording's already started. Okay. Feel free to basically how we have structured this is that we're going to present some of the new releases or new updates in the current release, show you some of the up and coming stuff that's happening with us at Karamba. Are we frozen, Sarah? Or
No, we're not.
oh, okay, Clemens is frozen.
I can.
Okay.
Oh,
Oh,
just not moving.
okay. No, my screen is frozen. So anyhow, and at the end we would be open for any sort of questions or sort of comments that anyone might have later on in the session. So I'm going to continue with the presentation. So like I mentioned, we'll be showing some of the new features first, and then Clemens will also be showing some of these features live as well. Oops. So this Sarah has recently released this as a tidbit on our sort of YouTube and Vimeo page. Basically, we've done some updates to the model view where you can filter out different options according to this view input. So there's this video link, and Clemens will also be showing a little bit of that later. The BeamView has now all these different display possibilities, which is already embedded inside the component. So once you do the update of version, the latest version from end of January, you would already have this new component. Do not worry, your existing components will also still work for the BeamView. Now it's possible to assign stiffnesses in the supports, and you can do so, for example, like this, applying either the condition and then specifying the stiffness as a vector as such. We've done a little bit of an, let's say, upgrade in the line joints and also in the visualization of the line joints in the model view, and here's just some quick images of the line view. We'll be showing that a bit more detail too. And some of you might have already seen this. It's currently work in progress, but already available in the latest release. But there's this possibility to enable async for specific components, namely the assemble model, and the analysis components or the algorithm components. And some of you have already seen this in a lot of our previous videos, but the latest version also includes export and import functions for the structural model for Speckle. So feel free to also experiment and play around with that. And check out some of the videos also if you are interested in looking into this export and import model function for Speckle. So with that, I think Clemens, you will jump into a live demo.
Yes, let me just share my screen.
And feel free to post in the chat, introduce yourself if you want, and we would like to meet everyone from the community too during the session.
Okay, just a second. The first example that I would like to show is about the new visibility options. Just a second. How can I? Yeah, the new visibility options. You see here, kind of roof on columns and some ribs underneath the plate. And first of all, this all looks a little bit congested, I would say. So if I take a look here now at the components which create the output, the first thing would be to disable, for example, the element numbers, or for example here the element axis, to get a nicer view of the rendering of the floor plate. And here in the ModelView component, it's not possible to supply several pieces of data to specify what parts of the model shall be visible. So the first option is to choose elements via the element ID, like for example, roof. It shows only the roof, or the columns, or if you want to see the roof and the columns, you can also add here both. So if you add here multiple elements, they add up, so to say. Then another option would be to choose elements by their index. So if I enable here again the element numbers, you see here there are quite a lot, and the first 5 are here. And as it's always possible, one can always use also the element index as the element name, as you can see here. Then another option which already existed is to use regular expressions, which start with this ampersand. This means, for example, show elements 1, 2, or 3, or 4, or 5. So, or the same here. So with this regular expressions, it's actually possible to do a very refined selection of the elements. And now what's new is that besides a closed volume, a BREP, which was already possible in the previous version, it's now also possible to supply, for example, a plane. In this case, a YC plane. And you see then all the elements which lie on this plane. So in this way, you can specify sections through the building and see the results only at specific sections. Same applies to differently oriented plane, like here. And also all the, of course, all the examples are also then connected to the visibility of the elements. Then if it's not a plane, it can also be a baseline. The baseline actually is used to define, again, a plane. So in this case here, it's a small piece of line here, which specifies that all the elements along that line and in the vertical plane are visible. And nearly the last option is to specify the view via a surface. And in that case, only those elements which are in the surface are visible. Or the last option is to have a closed volume, an arbitrary one, and then you see all the elements which are inside the volume. As you can see here, the roof is also visible because there are some points which are inside. So it's actually only necessary that some nodes of an element are inside the volume to make it visible. If I take a look now at the columns and the beams, can show you also the new possibilities which are available here at the BeamView component. So in the previous versions, it was possible to show the rendered cross-sections of the cross-sections, of course, the displacements here, stress strength ratio. you can see how the stresses are distributed in the elements. But now it's also possible to visualize results along an axis. So for example, a utilization, there's one value per position on a beam, and this is now rendered as a colored line where you can increase or decrease the thickness if you want. Can also double click here, can increase the scale. And see how it deflects. So utilization of the element, the total one, then according to normal forces, shear forces, and so on and so on. In case of multiple load cases, I mean, in this example here, there's only one load case, but with this option, it would be possible to specify that along the beams, one can then see the number of the governing load case, which is displayed here, or sigma min, sigma max buckling length, which is given here as negative because these values were generated via the Karamba assumptions and not set by the user. Okay, that's basically. I hope, are there any questions maybe from your side? Otherwise, I would go on to the next example.
As I wrote in the chat, we will be sharing the link to the files later on, so don't worry.
Then there's one which is similar. Okay, I overdid it here a little bit. It's a structure which looks like this. And here you can see the new support option, namely that it's possible now to supply here a spring stiffness, a translational spring stiffness or rotational spring stiffness at the support. And so this can be used then to simulate the structure soil interaction. For example, you see here now that the supports also move a little bit because they're not infinitely stiff. The according symbol is somewhat more lighter green arrow than the fully fixed support. And again, it's here possible to supply different viewing options via planes and surfaces and so on. And here the proof that the colors here really correspond to the utilization. You see here 12% corresponds to 0.12 here at the utilization component. And by the way, this was sometimes a source of misunderstanding because in previous versions, Karamba also showed here a utilization entry, but actually this was only stress per the actual stress divided by the strength of the material, and the utilization is actually that utilization which is according to Eurocode, so including buckling length and complete cross-section design. So this is that. Another, then Matthew mentioned that we improved the handling of line joints. This was previously a little bit complicated because one needed to specify exactly in which direction the hinge should be placed. So for example, here now, I don't have to specify anything anymore. You see here the Y direction was used to specify the direction towards the surface to which the line joint is attached to. But in that case, since this here is a naked edge of the shell patch B, it's automatically detected by Karamba, and you do not have to specify any directions here, which is quite useful, especially if you have more complex geometries where it's hard to define the direction towards the surface where the line joint shall lie. And also we improved the rendering of the line joint, so now it's very clear on which side of the line, so on which surface this line joint actually lies. And the option of specifying here directions is still available, because in complicated cases where there are more than two surfaces joining each other, it's still necessary to specify on which of these three or more surfaces the joint shall lie. So in that case, you still need to supply directions here. And yeah, that's basically it. In very, very complex situations where the orientation of the joint continuously changes, you can supply here the direction at the beginning of the line joint, and then it will automatically adapt to the changing position of the surface. Okay, and the last thing, optic cross-sec large. This is something, again, a little bit related to the viewing option. In this case here, the cross-section optimizer tells me that for some elements the optimization didn't converge. That's usually because of some stress peaks or whatever. And now there is the option to visualize which elements cause this message. So there is a special notation. So if element number 0 is a shell, then you can supply here the index of the face, which shall be visualized. In that way, you can see where there are problems in the structure. By the way, we will improve this optimization component further in the future to make it more versatile. Because at the moment it gives you this warning, although the design is probably okay. The reason is that this is the optimization is an iterative process, and so if after like 10 iterations there are still changes in the structure, you get this warning. Although in case of a plastic material, like for example steel, the design would be okay nevertheless. And one other thing which I would like to show here before I hand over to Matthew again is this option of enabling async execution. By default, it's turned off because, I mean, for smaller definitions, you probably don't need it. But for larger ones, it can be quite helpful because it seems to interact with my screen sharing. Now it's stuck, sorry. But what it is about is that this async execution of components makes normally the process of creating a definition easier and more fluent, because the components do not block the UI anymore. So unless you are doing a presentation with Teams, the components work in the background, and your progress isn't impeded by the calculation. However, one thing, also besides the fact that it's not compatible with Teams, is that in case of optimization with Galapagos, for example, or doing loops, one needs to disable this option, because otherwise it crashes Galapagos. And in our experience, it works quite reliably, although Grasshopper 1 was not actually intended to have async components. I mean, we are using the async component of Speckle as our basis, so to say. And yeah, this works normally quite reliably. Okay, I'll hand over to Matthew.
In my experience, Clemens, I've also used the async on a Teams call,
Yes.
so it should work actually, but maybe sometimes.
Yeah,
Yeah.
oh no. It's a little bit weird sometimes. It behaves a little bit weird sometimes, but normally works quite well actually. Yeah.
There was a question in the chat from Raphael regarding this spring stiffnesses.
Mhm.
I'll just read the question out. Can we assign a custom spring stiffness value to only one of the support components? For example, if one wants to assign stiffness value only to the translation on X, but keep all the other components infinitely rigid.
That's possible, yeah. I have to. No, my
No.
my Karamba grasshopper is completely stuck. But it is possible, yeah, to define both. You can, yeah, if you do not supply a stiffness, and also you can combine two support conditions at the same point, and they will add up. So you can add support for a rigid support and a support for spring support, and this will add up, and then you can combine them. Yes, that's possible.
I think there's a few other questions, but let's maybe jump on to. I'll just continue the presentation. I think we can come back to some of the other questions after. Hopefully, Clemens can fix this.
Yeah, let's see. I have to kill it, I think. Sorry.
So I just wanted to touch on some of the upcoming features that we are currently, let's say, immediately working on. So, I mean, some of you might have seen already, there's a work in progress of new Mesher available in the current version of Karamba. Those of you who've enabled the work in progress, but we've been vigorously working with one of our developers, Maya, who has been vigorously working on a new Mesher to basically have more functionality. And we're still in the process of testing it, but we're very excited to basically launch it very soon. And hopefully this will make then the meshing process much easier for everyone as well. For some of our Japanese users, this might be interesting for you. I'm not sure if many of you are on the call today, but we've been collaborating with our partner in Japan and students at Waseda University and engineers at Shimizu to develop a Japanese UI. Some of you might have tested the Spanish UI. This is something where we're currently working on, and I think hopefully in the future, I think what we're planning to do is also make the repository public, if I'm correct, Clemens. So if there's anyone who's interested to develop or do translations for any other language, we're open for contributions from anyone too. And lastly, just to touch on some news and upcoming workshops and events. Clemens will be speaking at the Rhino user meeting at the end of next month in March in Basel. There's still places available, and I think the early bird is until 1st of March, so feel free to register and catch Clemens in Basel. For some of you who are interested in optimization, I'll be hosting a workshop tomorrow at 5 p.m. Central European Time. This will be co-hosted by Sustainable Design Network, and there are still some places available. So feel free to sign up, and you'll get access to the files. It's a 2-hour workshop and recording as well. And that's it for the short introduction. And I think Clemens wanted to show also a little bit about our roadmap. I think some people are also asking about that too, right? So I'll stop sharing, and then maybe Clemens can also share something about our GitHub, where he's basically in the last weeks reconfigured the roadmap, the bug reports, and the feature requests to sort of show how this is now being tracked and how we plan to sort of document all this.
So if you go here to nightly builds on GitHub, you see this landing page where you can also get to the current versions and work in progress versions. And what we also had already was this bugs or feature requests where you can add or post bug reports, requests for new features. And here we have also laid down our roadmap for future developments. And what I will do in the future is that whenever a user finds a bug and reports it on the McNeil forum, I will also post it here so that one can see at one glance what known bugs exist and how far we've already removed them. Yeah, and if you have ideas for new features, then please post them also here, and we will try to make them happen. The other thing is the roadmap. And what we also will try to do is to have discussions about features. But here you see the main tracks of development, like composite beam cross sections, then the new meshing component. Yeah, the development of the speckle import export is still going on, but is nearly finished, I would say, and it's already in production code. And here, for example, design procedures for American and Japanese codes, multi-point constraints, Grasshopper 2 user interface. Let's see how far we can get with Grasshopper 2. Okay, that's basically it. There were some questions. Which joint component would be the most suitable to represent the joint as shown in the screenshot? Oh, and it's a little bit hard to see what the exact joint conditions would be. But basically, joints are added to the ends of beams. So in case you have a very complicated node, this so arbitrary joint configurations should be possible to simulate. The only thing one needs to be aware of this is that whenever you add a joint, one adds also 1 degree of freedom. So in case there is one node which connects only to joints, then it might be that the node itself gets movable and then forms a rigid body mode, which is then sometimes hard to track. But otherwise, it should be possible to simulate any type of joint. Then, is it okay to use Mac for the March? Yeah, the Mac version. That's a good point. We are trying to bring out Karamba3D also for the Mac, of course. But the problem currently is that especially the new Macs, they do not have an Intel CPU anymore. And so the Intel math kernel library, which we use, MKL, is not available for the latest Macs anymore. So before we can bring out a new version for the Mac, we have to find a replacement of this Intel library. So it will take probably some more weeks. But and in Basel, actually, it's not a workshop, it's rather a talk. So as far as I remember, on the 27th, there are 3 workshops. But there will be no Karamba workshop. So it's a talk that I will have on Friday. Okay. Is there a way to list the model elements, the nodes, the elements, and so on? Yeah, it is. Let me just start Rhino again. If you want to disassemble a model and see what it consists of, I think the best option is to use a disassemble model component. It's taking some time to start up. I think I destroyed it. And it doesn't want to start up anymore.
Maybe I can load it up on Gitbook as a sort of explanation.
Now it worked.
You have it, or should I share? Okay.
Yeah, I can open. Let's, for example, use this example here. Recovery. Okay, so if you want to see what the model consists of, I think the best option is to go here to disassemble model. This shows you all the beams, all the cross sections, and so on and so on. And this disassembling of a model is actually something which is very useful because this disassemble model is the opposite of assemble model. So if you use here the output and format.
Clemens, you have to share your screen.
Sorry. That's a good tip. Yeah, here we are. Sorry. So model, disassemble model. It's here. And this gives you then a list of all the beams, supports, and so on. And the assemble model is the opposite, and you can create a new model by adding here those with the joint here. And this gives also the chance to add or to modify something here in between and to update the model in this respect. And this disassembling of an object is not only possible for a model, but also for elements. You can get now the cross sections, but you can also then disassemble the cross sections to get some information. And the last step is then to disassemble the material, as you can see. So this way you can get a very refined grip on the model. Thank you for the question. Are there any other questions? Let me see. Load combinations. Yes, there is a load combination component, but the predefined load combinations are required. Can it be added to the roadmap, for example, for Eurocode 3? Yes, this is something that we can do, and that we will do, because it's actually not very complicated. That's a good tip. I'll add this because it's easy. Yes, thank you for this feature request.
There was a question about, I think maybe Clemens showed it in the GitHub roadmap, but was more relating to the implementation of ACI and AISC. I mean, you might have seen that one of the feature requests that we are currently working on, and we started, is the American Steel Design procedure. So that is something that's definitely on, let's say, immediate development roadmap. Can't give you an exact, let's say, time yet, or Clemens, but that's something that we are currently working on.
There's another good question. What is the actual logic behind large deformation analysis? Is it containing dynamic relaxation. I'm wondering if I can do grid shell optimization with that. Any tips? Yeah, at the moment there's this one large deformation component here, which is used for form finding. Where do we have it? Here, that one. This is, however, only for form finding because it works in such a way that it subdivides the load into small steps, or the loading steps, the full load into small loading steps, and then continuously updates the displacements. And in this way, comes close to a geometric nonlinear calculation. However, it doesn't include a iterative corrector step. So it might be that the displacements gradually shift off from the correct path a little bit. And for deformations, it's not, or for shape and form finding, it's maybe not so important. But for calculating the stresses, this would give wrong results, and therefore this large deformation option for form finding doesn't allow to retrieve stresses and forces. There is a work in progress version of large deformation analysis, which you can test if you enable here the work in progress versions. However, this, where is it? Oh, large deformation analysis. Not, yeah, this analyzed nonlinear work in progress. This contains three methods: dynamic relaxation, arc length method, and Newton-Raphson iteration for dealing with the geometric nonlinearity. However, it's not yet in a state where it works all the time, let's put it that way. So if it converges, then you get correct results, but in many cases it doesn't. It's still something which needs to be improved. So for grid shells, however, it's normally not necessary to do this kind of large deformation analysis, because this means that the deformation is so large that the in-plane or actual forces of the elements are influenced by the transverse displacement. And this is normally not the case in structural engineering problems. In case of grid shells, you're rather interested in whether they buckle or not. And for this, it's sufficient to do second order theory analysis, which includes the P delta effect, it's sometimes called. So the fact that if some beam is under compression and it bends, that the bending moments are increased by the compressive force, and which then leads to buckling. So for grid shells, I would say this is the proper way to do it, because it allows also to include multiple load cases and so on. So this is normally much faster and also normally reliable enough to do the design of slender elements, which are under danger of buckling. Okay. Did I again didn't share the screen? Sorry. but I didn't show much in the definition actually. But no, maybe yes, because I showed how you can enable the. Yeah, here it is. I showed here how to enable the work in progress version component so that you can actually see here the large deformation analysis. Sorry. Okay. But as I said, most of the time, this second order analysis is good enough and actually the way to go for grid shells. Okay.
There's quite a few questions. I'm not sure if we're going to be able to get through all of them, but I will try. I'm answering some in the chat, but maybe Clemens. One question was, does the automatic optimization component of sections, like optimized cross-section component, also include the verification of non-buckling of the bars?
Yes, it does. Well, let me again share my screen here. The cross-section optimization consists of two parts. The first part is to ensure that the ultimate limit state is adhered to, so that it doesn't, the structure doesn't collapse. And the second step is to ensure that the deflections are not excessive. And in case of the ULS, the ultimate limit state iteration, buckling is included. However, you need to make sure that the assumptions are correct. And for this, it's utterly important that the buckling length of the elements are correct. And I mean, here we have some weird lengths, but as you can see, there's a buckling length specified here of 3.3 meters. It goes from here to here. And the buckling length means it's the free length of the element between some hypothetical hinge at the beginning and at the end of the beam. And this needs to be correct. If this buckling length is inadequate, then the results of the ULS design can be hugely wrong. So this is important. Karamba does use some built-in assumptions. So if you do not specify anything, the buckling length can be specified using a modify element component. Here you can set the buckling length. So for example, if I want to set the buckling length in the Y direction to like 8 meters, I can do this here. This should be now here. Yeah, now we have all the members have 8 meters buckling length. And the assumption which Karamba does take is, first of all, if you supply here at the element creation component a polyline, then the buckling length is set to the distance between the starting point and the end point of the polyline for all segments. And this is one thing which is used. And in case it's only a line, then Karamba tries to find the nodes which connect to more than two elements. So it starts here at the element and then proceeds towards the starting and end point of the element and looks for nodes which connect to more than two elements, and these nodes are then assumed to be fixed in space. So meaning in that case here, it would mean that the buckling length only goes from here to here, from here to here to here, from here to here. Can be correct, but as you needn't be correct. So the most important thing when you apply ultimate limit state design is to have this buckling length correct. Okay. I hope this was understandable.
I mean, just to add on that, because there's been a discussion about the optimized cross-section component. You do need to input a list of cross-sections for it to optimize. And the order of the cross-sections is also very, very critical, because basically Karamba goes down the list from top to bottom too.
Yeah, it assumes that the best cross-section comes first, and then the next best, next best, next best. And by default, the cross-sections that come in the cross-section library, they are sorted by their height and not by their area. So, and the reason is that otherwise, if you sort them by area, which would be the logical choice if you want to reduce the material as much as possible, if you would optimize towards area, then you would get structures with cross sections where the height varies quite frequently, and sorting by height gives you economical structures, but also at the same time height distributions which are more realistic.
So I think we are approaching the end time. I think maybe there was one last comment, I think, from Victor. To confirm if I understood correctly, buckling length is the theoretical length of a column in which, under the current load and cross-section, it will be buckle. If the real length of the column is shorter than the buckling length, it will not buckle.
No, that's it's a little bit different. Let me draw it maybe. So for example, I mean there are these classical so-called Euler cases. So if you have a column which is hinged on one side and then straight down, also hinged here, and then here fixed, then it will buckle like this, for example. If you have boundary conditions which are different, like for example, you have here a fixation so that there are no rotations possible, like for example at the floor slab, and here maybe also, then a column which is here in between will buckle differently, namely in such a way that here there's no rotation possible, so it will go like this, and then like this, and this, and there will be here inflection points where the moment is zero, very much like here. And so the distance of the inflection point here is just 0.5 times the length. Or another case would be if you have a freestanding column like this, which is cantilevering here, then the buckling lengths, the buckling pattern would be like this here. Sorry. So there's one curve, so up here, and you can look at this. Here's a zero moment, maximum moment, and it can be seen as like a column which extends into the ground, and the buckling length in this case would be here 2 times L. So these are the Euler cases. And in a real structure, since you normally do not have a real hinge somewhere, but only some maybe a connection which has a certain spring stiffness, it's not easy. But in that cases, you could use the Karamba buckling component to see what the buckling shapes are, and then from those buckling shapes you could then determine the approximate distance of these zero moment points. Okay, yeah. That's that.
So I think we'll just have one more question. I know there's a lot of questions from everyone, but there was one last question. So it's relating to the distribution of block loads on several beams which have been discretized into separate smaller beams. I do remember, Clemens, that we have an example where you wrote a C# component to do this.
Yes.
But I think this is something that has been on our list of something to improve, definitely, right? As far as I understood.
Yes. I mean, just for the loads, it's relatively simple. There's a script, as you said, Matthew. But it would also be, of course, nice to have this linked together beam elements, also for querying results, for example, not only for setting the loads. And this is also on our list. And this would be really nice to have, yeah.
Yeah. So we can share this example. I don't know. I can't remember where it is. I think it's in the examples folder that's included with the installation. But as Clemens mentioned, we're definitely going to be working on improving this. But unfortunately, we all have to leave for other appointments. But we're very happy with the sort of with everyone who joined us today. And all the questions that people are asking. So I think because of the success we are, maybe probably going to definitely have more of these sessions coming up, and we'll discuss internally when the next one is. But definitely thank you everyone for joining us today, and we're always excited to sort of see everyone from the community and also connect with you all. And hopefully Clemens will see you all in Barcelona. Oh, not Basel, in
Basel.
Basel.
Okay, yeah. Thank you very much for joining, and yeah, see you next time. Bye-bye.
Bye.